Welcome back, everybody, to the Friday Open Studio design sessions. Um, Today's session is going to be a little bit different. It's going to be a little bit longer. It's going to be 3 hours. So I highly recommend, if you're new around here, if you don't know what this is for, this is really intended to be an Open Studio design session. So really you should be working on your projects if you want, and I'll be working on mine, and we can both work on our projects at the same time and have kind of a studio environment through the internet. um, and that's kind of the whole concept behind this, so I highly recommend you get out your own projects and start tinkering. I feel like that's a little bit more interesting than if you just straight up watched the stream uh, and just watched it. I guess. Sorry, it's a little awkward, but anyways, today's stream we're gonna continue working on the Astra here. This is the YX10 M1 variant. This is basically the second version of the Astra. And as you can see, it's pretty well built. It looks almost complete, but it's not really quite there yet. I personally want to finish off the bottom side here, at least sometime soon. And then we can work on the vertical stabilizers and then call it done for this project. And then, obviously longer format stream. Yeah, today's gonna be an exception. Day and tomorrow I'm gonna do a stream tomorrow at the same time, 5:30 p.m. tomorrow. And this is really to make up for lost time. I know, like, the week of Thanksgiving and the week of 4th, last Friday or 2 Fridays ago, I actually missed a stream. So this 3-hour stream today and tomorrow hopefully we'll make up for that time, and then I'll be off until the new year comes, and then we'll continue off back in January. But really want to take some time off, and be with family and things like that. So I probably won't be streaming next Friday, but I might do additional streams this weekend, just in general, like on Sunday and be Monday and Tuesday. I'm not really sure yet, but hopefully we can make some decent progress with this project right here, which is the YX10 M1 Astra. So Astra M1 is the way I've been calling it. So anyways, I guess we could start off with a brief update on what we did last time and what we plan to do this time, like we usually do in these streams near the beginning. Last time we designed and built and integrated this fairing structure right here, which is made out of cardstock, the same cardstock material as the rest of the fuselage. It's really stiff, right? It's quite strong. And let me just grab my pencil right here. You can see that there's a slot cut out here for the landing gear mechanism. Right, so the whole point of what I'm doing here, creating this aircraft design, is that you have different moving parts, like for the canards here in the front. Right, this is a flight control surface. Right, you can see that the angle is changing. You can also change the slat angle. If you're new around here, this is what we've been working on. Yeah, so it's very, very delicate mechanism, but it's pretty cool, I think. Should help with high angles of attack. Maybe not on this scale, but it certainly looks cool. And the third mechanism that's in this design is the landing gear system here. So this landing gear is just made out of paperclip, and it's in tension, it's in pre-tension, so that means that it wants to be deployed naturally. So you can see that if I push this mechanism in, it actually pops out because there's an elastic band in there. So you can actually watch some of my previous streams to see the inner workings of this design. I have a notebook here with a bunch of sketches, but I doubt they'll be super useful because it's well, first of all, this doesn't really show you how it works, and second of all, when I do draw the mechanisms out and you know, display them here, it's really hard to understand like what's happening. Like you have a metal structural base and then a little fulcrum here, the landing gear itself, and an elastic band pulling on the other side of this fulcrum to give it that pretension so that it'll come out like that. So it's kind of hard to understand. It's not very easy to draw wire structures because wire is super thin and you don't want to. I don't actually, to save time, I don't want to draw like cylinders and shade in the cylinders. These are really like schematics more so. So like the actual fuselage and things like that, I will like shade in to express shapes and things like that because that's actually necessary. But for these mechanisms where you have functional bits here and there, I just simplify it down to these symbols. So last time we built and integrated this fairing, and we pretty much agreed, well, kind of agreed to myself in the design process that this fairing is actually quite massive. Like if we zoom out a little bit and look at this is yeah, it actually ruins the side profile a little bit, but from the front it looks more interesting, I guess. It's a little bit more beefy, but from the side it just looks a little chunky up front. So for this rear set of landing gear, we're probably going to have to go with a different mechanism, which we went over last time. This is probably going to be this design right here. And I don't think we're going to be building that today necessarily. We might get started on it in the second half of the stream, but right now, the priority for this stream, as of the current moment, sorry, I'm just adjusting this mount real quick. The goal for today is to really complete this middle profile, right? If you notice, this fairing actually it kind of leads up into the fuselage, and I want it to be kind of straight and then rounded up near the tapers up near the end, right? That kind of looks more aerodynamic, and also this additional structure here might be able to help us with a latch system so that we can actually prevent the landing gear from popping out. So we need some form of restraint on this landing gear, pretension landing gear element here, right? So you need like a little hatch that slides back and then releases it, slides forward again, something like that. And to do that, we need to also build a little bit more structure here, which actually will fix up the weird side profile right now, because right now it kind of slants down like that. I want it to be more horizontal and then tapered near the back. So that's kind of the goal here. Yeah, this part right here right now is struggling a little bit to keep, I guess, attached. So we're gonna actually start by doing some repair work. Gotta get started with today's session of tinkering with a little bit of fixing up here. So this tape isn't sticking down, unfortunately, but luckily we can use tape to fix down tape. So I'm gonna try doing that. Actually, yeah, just kind of extend the tape in a way, and then press it down so that this piece doesn't lift off. This is a difficult piece to assemble because it's high curvature area, right? There's a lot of curvature in this region where the fuselage kind of slants down and then goes flat here, right? So it's a little bit hard to really get right in terms of adhesive attachments, but hopefully with a longer piece of tape with more surface area we can grab on. And yeah, this looks okay. All right, so we need to build something here now. That'll hopefully help us with the restraint for the mechanism, because we need a cover, right? When you're in flight, you don't want this hole to be gaping out like that. I mean, I know like some airliners actually do have like open landing gears. You know, they have the wheel exposed to the passing air. Um, and you know, that's interesting and all, but I don't think that's ever a design choice made in fighter aircraft, which this is supposed to be simulating. But yeah, it's always nice to cover up your wheel well, right? So this is the wheel well, I guess. So I do need to come up with some concepts, because I really haven't thought much about this. So I'm probably gonna sketch a little bit first. Just gotta figure out some way of restraining that. Right, so we need some type of sliding system, sliding mechanism, or something like that. Just orient it like this. The difficult part about sketching in a sketchbook is that this page doesn't fold perfectly flat, so you're always fighting it a little bit. If you have like a spiral bound notebook, it's a little bit easier, but yeah, just gotta be careful not to. This thing is really rigid, so it won't break necessarily, but it's you gotta be careful, because this is, I don't know. I think it can handle landing loads. It's just not strong enough elastically. But anyways, I am going to sketch out some concepts. So we need to have like some sort of fairing that, okay, well, first of all, the fairing right now kind of goes like that. So we need something to counter that shape, right? So like a very thin triangle like that, and then tapers near the back into the fuselage, right, where the yeah, I'm just gonna draw a rough silhouette of the design here. So something like that. Hopefully it's a smooth transition, but if not, that's okay, because this is already pretty angular. I want it to be a slidey mechanism. So some sort of, I don't know, like a door that has like a, so yeah, this is going to be a little bit difficult, because sliding parts, they require rails, and rails are kind of hard to do. So right now we have something that looks like this, right? Got a hole right in the middle. But if we have like some sort of C-channel part, that slides back and forth, right? This thing goes back and forth. You might be able to cover it. Also, that's kind of hard to do. So I'm thinking like, okay, right now we see this kind of a perspective on the fairing with the slot right here. What if we had like a part that went like that, and then off to the side it was like an angle piece here. It's like a triangle piece. Oh, it doesn't even have to be that. It could be, yeah, the point is it needs to be rigid, because we don't want it to just flap open. I don't know. This is quite difficult. I haven't thought about this. um, we could do side swinging doors. I guess that could work too. It's just I don't know how to implement that. Let's see. Well, we could just use the fact that folding hinge, right? So you have two pieces of paper, and if you crease it hard enough, it becomes a loose sort of hinge. I was thinking maybe something like that could do the trick, right? So I'm feeling like that might actually be our best choice here. In terms of a securing mechanism, but it's gonna be hard to implement, right? Because if you have just paper covering over, even if it's one piece that goes over like that, it's gonna want to pop out. So it's not that easy. So wonder what would happen if I actually, so I have made in the past these friction lock modules, right? So you have like a straw, large diameter straw, and then two smaller diameter straws, right? Kind of look like that inside a bigger straw. If we somehow leveraged that and maybe a slot, that, I don't know, somehow pushed a that's gonna be kind of tough. I feel like something like this, because you're adding a little bit of thickness, and let's actually do a dry fit here. I just need one of those larger diameter straws, but I'm starting to run out of those Dunkin' Donuts straws. Like, I have a bunch of these black straws that I got from college, but yeah, these large diameter straws, they're tricky. Good. All right, so we got. Maybe we could just work with thin diameter straws, honestly. And make a paper bearing, maybe, or something like that. And then somehow slide it across. Right, we could cut half of this off, create a C channel. That would slide over here. I don't know. I haven't really thought about this. As you can tell, probably. Yeah, this is a tricky problem to solve. Mainly because I didn't plan this out ahead of time. Maybe we need like some sort of compound sliding door. So we have like a triangular bit back here, right? And then this part, flips out, right? It's like a triangular piece that covers the slot that looks like this. Right? Something like that. Sorry, let me just zoom closer. I'm not sure if I'm making any sense, but let's try and draw that a little bit better here. So we have this piece right here. And then a panel that pops up here that also has a piece there. Do you kind of see like what I'm getting at here? It's a little bit complex, but something like that. Maybe like a little protrusion here so that it interlocks with this. But then this flips up and then this slides back and forth. Right, so to deploy, it would slide. Okay, so it would slide back and open up like that, let it come through, go back down, and then slide forward. But that's a lot of moving parts, and I'm still not really sure how to secure this linear moving piece here. Right, so this is very interesting, I guess. What we could do with a popsicle stick. Just exploring different materials and different ideas based on that. With a popsicle stick, we have a very flat edge, right? You can actually, if we zoom out a little bit, we can make a decent side profile. Kind of smooths it out a little bit. This is a pretty curved piece, but you can find one that matches what we need. We can build around that and also use this thickness as sort of a I don't know, rail of sorts. Does that make sense? Yeah, makes sense to me. And nice thing about this is it's actually pretty simple. So all you have to do is align this up, right? Make sure that you're about there. And we have a decent bit of moving here, moving space. And then we can have some sort of paperclip rail thingy that slides along this piece. I think that's the idea that I'm gonna go with, because honestly, that's probably the most straightforward way to do this without building paper structures, which I mean I'm gonna have to do anyway, but it's a little bit easier to build off of what you have instead of inventing something completely new and different. Alternatively, we can build a rail for this piece so that this entire thing moves, which would be mad. That would be absolutely insane if I did that. But that could also work, because this wood is very strong and it prevents the thing from going through without reinforcing like the cardstock paper that would otherwise be the cover, right? And then all it has to do is move a little bit. We don't even have to make it this long, although we probably should. So if we can somehow build a rail for this thing, I think that's gonna do the trick. So you need to build a rail for this piece that slides up in here. Another problem with, I mean, I'm just thinking about the future right now. So when we build these landing gears off to the side here, we have to have some sort of restraint mechanism that's not this complicated. So that's definitely going to be a problem to solve. But yeah, this is quite interesting. Yeah, in order to do that rail thing, we'll need paper clips to really secure this in place. Or maybe even like cut a slot in this, because that'll actually perfectly restrain it in place. It's gonna get hard either way, because if you have a moving piece, it's just hard to control its movement, and you introduce more places where tolerance issues can arise and things like that. I'm liking the idea of keeping this in place and then having something that slides across here. I feel like that might be the more stable option. The doors are hard, right? Hinges, doors, mechanical moving pieces. They are hard to get right. All right, let's start to think about what kind of a shape of wire we would need to wrap around something like that. I'll just keep this to the side. All right, 5:30 to 8:30. That's gonna be the stream today. I'm just talking to myself. Anyways, so we got a piece of wood, right? Has a thickness, has a length, has a width. So this is what it looks like from the front, and this is what it's gonna look like from the side. How do we build something that wraps around this, right? right, so let's see. We need something that. Hmm. So. So we want the main piece to look something like this. It's going to be a really tight bend. But it's going to help keep everything in the same plane, more or less. And then, well, that works here, but so this is an interesting topology problem, right? If we think about the geometry needed to hold this in place, it really comes down to some type of loop, right? But we need to add more functions to that loop. We can't just have a tight band around that. So we could have, okay, so let's go with that idea, right? We could go with something like this, wraps around, goes like that, goes in, goes to the front, spreads apart here, and then comes back together, but it's gonna be open, right? And then, so that thing, this component can slide back and forth if it's well made, if it's the right tolerances. And then we somehow need to be able to attach things to it. So right now what we have is something like that, right? And then, so the hatch is gonna be like right here. Right, we just need to slide this thing, which will have hopefully some sort of cover. I mean, not hopefully, it will. So we're designing this. So this whole thing slides forward after this goes in. Landing gear, go in. This thing slides across. Easy enough, right? Well, what if from the top, draw a top sketch here, just really quick. It's a popsicle stick. We could chop this into a square shape, it doesn't really matter, but I'm just gonna leave it as this for now. What if we built something like this? I don't really know how it's gonna be attached, but it's just gonna be attached somehow. Well, we won't worry about the details right now, just the concept, right? And then this whole thing slides forward, and then has a loop like that, right? But then across this gap, we put cardstock so that it I just don't know if like cardstock is strong enough to hold the landing gear back in place, you know? But we can try. If it is, then this idea will work. If we can get a sliding piece here on this popsicle stick, which I'll designate with crosshatch texture. right? Something like that. This paper clip with a little bit of thickness here can slide forward. That could maybe do the trick. Yeah. Now the question is, if we do a loop like that, right? How do we get it to wrap around a square or a little rectangular cross section, right? So we could go up here. Actually, we could make it go in, and then something like that. Because what makes a good sliding piece is not necessarily two loops like that. You know, if we have two loops like that and they're rigid, I mean, it might be able to slide, right? But would this work? No, we need something on the other side to hold it in place. That's the problem. Okay, I gotcha. Yeah. So this is essentially open, right? If we look at it from the side, it looks like that. The two pieces here, like that. So we need something on the other side. So this is... comes up like this, goes in, goes back out, goes down. That's still a C shape. All right. Let's try again. See, it's trial and error, right? You just kind of see how it goes, and then all right, just drinking a little bit of soda to stay caffeinated. Ooh, all right. Okay. So it's not gonna be like that, but we need some clever way of I don't know, if we go in underneath and then support it like that, would it work? It would, but then this is an extremely long loop, right? So this length, we need to figure out how long, and then all of these lengths will have to just work with the actual material. But I don't know, I feel like this might be able to do the trick. Yeah. Maybe. It's a huge maybe. If we want to design a nice sliding door, this is what it takes. This is gonna take a lot of tinkering. I don't know where the popsicle stick... Oh, it's right there. We got it. Alright. So I think we're gonna use this one. It has a nice little subtle curve to it, and we use that to our advantage. But how to wrap a paper clip around a popsicle stick? That's the question here. Excited for the longer format system. That looks good. Sorry, I'm just reading some of the comments. Again, if you have any questions or comments or suggestions, please feel free to voice them in the chat. But yeah, this is interesting. I'm just kind of like mumbling and like futzing around, but that's literally what the design process looks like. I don't know all the answers. If I did, it wouldn't be design. It would be I tell you what it is, and then it is. So a lot of this hobby comes down to experimentation. So That's where the fun of the hobby is, in my opinion. So let's see. Let's keep that there. So we're gonna try and unravel this thing. Yeah, it's gonna be kind of hard because I just clipped my nails like a couple days ago. So without nails, this is gonna be kind of difficult. We also have different types of paper clips. So the kind you see here, the silver uncovered type, it's a little bit thinner. So I wouldn't use it for like structural purposes. I feel like even though it's quite strong, it's just I wouldn't use it for that purpose. I would use a higher gauge wire, steel wire, paper clip for more structural purposes. I mean, the hinge itself was not made with this, right? Like the mechanism inside. Anyways. All right. Zillow. I don't know where that came from. Look at me just salivating, thinking about the design and just like, oh, that's delicious. Anyways, sorry, I'm being weird. Anyways, yeah, so this paperclip, it's a little bit stubborn, but I think we can work with that. This is more or less what we need, but we do need to grab that and flip it out real quick. Shoot, that's kind of rough. Ooh, that's not good for the mat. Yeah, we really should use pliers for this. Let me just grab these real quick. Alright, got pliers. I bought these for 15 bucks. This is why it's useful, because it saves me finger pain. So it makes it a little bit easier to bend wire really tightly. Easier on your hands. You could definitely do it barehanded. It's just not recommended. It's gonna be a little bit more painful. Okay, so that does it. Now, I just need that sketch that we did. Try to roughly follow the concept here. Oh, wait, it goes the other way. So, I'm gonna start a little bit here, and then wrap it up, and then wrap it out, up, and over, in, down, over. So this is very intricate. I don't know if I can build this, but we're gonna try and see what we can do. Alright, which that doesn't really matter. Alright, so I do need like a centimeter of grab. I'm gonna call it grab. It's like the length of the C-section grips, you know, how far apart they're spaced. The wider it is, the smoother the sliding action will be. That's generally how these slidey bits work. Because if you have a shorter wheelbase, in quotes, it's likely to jam up, right? So if you spread it apart, it has a wide base, probably wider than the width, I would say is good. So if you draw a square, right? So like the width of this thing, if you draw a square, if you're wider than that square, you're probably gonna be good, mechanically speaking. Yeah. Wait a minute. What if I just like tightly coiled this and then had one coil go to the front and then tightly coiled it again. I guess that could work, but that's actually a lot easier to make too. I think I'm gonna try doing that. That's actually probably easier and better results because you get a consistent piece like that. Actually, if we do that, we can coil it and then spread it apart, and it'll be a bearing of sorts. And then we can fold the front like that to do whatever we want on the end. Okay, yeah, let's do that. So we need to measure how wide this thing is. So it's probably 1 centimeter. Yeah, it's about 1 centimeter. It's a little less than 1 centimeter, but when you bend things, it's going to change. All right, here we go. Okay, so I'll zoom in a little bit. All right, so I'm going to, this is really dangerous. I should probably grab another popsicle stick and use that one as the guide. Okay, I am gonna mark this one so that we know which one it is. Use this popsicle stick. It's labeled, so we don't mix up which one's which. I'm pretty sure this one is nominally still also 1 centimeter. It's a little bit wider, closer to actually 1 centimeter, but I think we should be able to get by with this selection of molds. Oh god, this is hard. What if I did that, folded the end over a little bit? Also, I forgot to mention this earlier, but if I'm having like streaming issues just like last time, let me know and I will switch to cellular. But if that's not a problem, I'm not gonna bother. So just comment to let me know the situation. But all right, so this I don't know what I'm doing. I'm just clamping this around. Yikes. All right. Yeah, I would not want to puncture my nail and bleed on this stream. That would suck. That would be a very not fun Friday evening for me. Okay, we can fold that down and okay, yeah, that kind of worked. Yeah, the problem with wires is that, you know, when you fold it, it tends to want to create these very sharp curves, which might not necessarily match the thing that you need, right? And unfortunately for me, my pliers are not thin enough to simulate this piece of popsicle stick wood. So I don't know if there's a mold that I can use. Maybe a pair of scissors. That's highly sketch. I don't want to injure myself. All right. Yeah, there we go. Maybe that'll do. That'll do the trick. Huh. Maybe not. Sorry, my fingers a little bit itchy. You didn't need to know that, but I told you anyway. So. Yep, it's always the first one that's really tough. And then it gets a little bit easier. Yeah, you see that? After the first one, it becomes a very tight piece. Oh god, it's so it's so tight that it can't even come off the. Oh my goodness. All right, yeah, this is because the way you wind it, it's just really difficult to. And I don't think this is long enough either. Shoot, man. God, that's actually really tight. Wow. It might be the first one that's too tight. I've accidentally made a triangle. I don't know why, but I've made a triangle. All right, let's pull this apart. Oh, yeah, there we go. Let's just see what happened here. Yeah, I don't think this is gonna work. All right, let's try this again. All right, let's reconsider the design here. If we have a piece in the back, right, like that, connecting up front, like so. We want it this way. This way looks a little bit better. Yeah. Actually, we only need like a little bit of movement to do that. And then the cover itself. Anyways, I'm trying to think right now. This is a difficult mechanical problem. I am not a mechanical engineer by profession. Well, I am, but you know, my undergrad in college was not mechanisms, unfortunately. I wanted to take a class on mechanisms, but then my advisor was like, "You're an aerospace student. Why do you want to take a mechanisms class?" So I didn't take a mechanisms class. And now I'm sad because I can't figure out this hinge. All right. So we only really need a little bit, but that's not going to solve the cover issue. It's still going to be an ugly gap here. Wonder if cardstock can do the trick. Let me just try and grab a little scrap piece of cardstock real quick. Alright, I don't have scrap cardstock. I think I got rid of all of it last time, but let's test this out. Let's experiment a little bit. So say we have a piece like that. So we're not going to use that anyway. How will it behave under load? Yeah, it looks like it won't really do much. I mean, it'll bend and curve, but that's about it. Okay, so assume we can use just direct, just cardstock to slide over. Yeah, I don't know. Alright, let's design a little cover here because I feel like if we work our way backwards, we might be able to figure out the problem. Um, this isn't like, you know, those guess and check strategy. No, it's not. We're not doing that. We're working our way back now. Where's the thing? This is the thing. This is the thing. All right. Okay, so we need to measure the width of this fairing structure. I think it's 1 centimeter if I remember correctly. Yeah, it's about. But luckily for me, I can take a scrap piece of paper. I'll be right back. All right, I got a scrap piece of paper. All right. Wow, we're at 1 hour. I gotta do this for 3 hours. Unbelievable. It's gonna be exhausting for me, but this is a sketch paper design. Yeah, I can't use that. It has my concepts on it. Let's do that. All right. Actual scrap piece of paper. V2, let's go. All right, so we're gonna just cut a little piece off here. All right, I'm gonna mark this corner, this corner, this corner, this corner. All right, we got 4 dots. Now we just connect the dots. I am so smart. Just kidding. I'm not that smart. Crying internally. Anyways. All right, so that looks decent, I think. I don't actually know what I'm doing. Then we use this as some sort of pattern. First of all, we need a perpendicular edge here. It's got eyeballs. It looks perpendicular to me. No, just kidding. It does not. Now it does. I'm gonna cut this real quick just to make things nice and square. Alright, so something like this. The shape isn't exact, but this is a prototype, so it's okay. Alright, so we fold this in half. We fold this in half. Right? So it'll fit over this. Yeah. Like that. Alright, so this is printer paper, so obviously you can see a crease there. The point is, if we make this in cardstock, it won't be like that, I think. Oh shoot, what just happened? Yeah, the power just flickered a little bit, so apologies for that. Anyways, if the Wi-Fi goes out, well, we're screwed. Well, if the power goes out, I won't have any light, and then I'll have to end the stream, so... Anyways. Let's hope that doesn't happen. Alright, so we got a little C channel going on here. I'm still trying to figure out how this is gonna work. I don't know what's happening. Let's see. This thing folds down to here, so we make a folding flash, or folding hatch. There we go. God, I can't even talk anymore. Anyways, So it folds out to let the thing go back in, and it folds back down. But then how are you gonna secure it? That's the big question. This is too hard. Honestly, I'm considering at this point just like making a piece that you just slide on, call it a day. That wouldn't be too terrible. It's not the elegant solution, but let's solve our headache right now, real quick. I'm really trying to figure this out. I don't know how to do this. Like a little thing here. God, this is probably the hardest part about this project, is making a freaking door for the landing gear. Well, we could just leave it as is, but then it's like ugly and it wants to come out, so Oh, I have a crazy idea. Let's go. All right. All right, so hear me out. Okay, hear me out. What if? All right, I'm gonna need a new sheet of this notebook. So you know how like the fairing is like this huge bulbous structure, right? So it kind of looks like that, and then the landing gear comes out like that. It just juts out, and then is its own loop thing, right? Something like that, right? And then connects to the fuselage down here. What if? And hear me out. This is crazy. What if we had a hinge here, right? That had a door the length of this height right here. So I don't have a. Oh, actually, I do have a compass. Nice. Oh fuck, the lead is broken. All right. Anyways, God, this is gonna be really hard with a broken piece of lead. Okay. Bear with me here. Just replacing this lead a little bit. Sliding it out. Okay. That doesn't need to be like too perfect. I just need a little mark here. What if I made like a hinge with a piece of material that goes like that, right? And this hinge has a little right angle piece like that, right? And actually, this is gonna be like the full length of this piece, the bridge here. I'm gonna call it the bridge, but it's the flat part. It's literally the flat part here. This covers the whole thing, and then we have the same thing on the other side. Oh fuck! I didn't use the compass. This is my one chance to use the compass, and I don't take it. All right, there we go. So, yeah, it does the same thing on the other side with a panel like that. And this could just be like a folding hinge. It doesn't even have to be like a, like an actual mechanical hinge. Because this, I doubt we're gonna be using this a lot, and cardstock is pretty strong, so this doesn't have to be mechanically complex. And then we have something like this, fold over, collapses in on itself, right? Then you have a layer like that and a layer like that underneath. And I want to say, like, what if we put magnets on this, but also, like, I don't think this is wide enough for a magnet. So I actually have a bunch of these little disc magnets that I think they're neodymium. So we could put one on the outside, but like, what would that do? That's my question. It wouldn't do any much difference. All right, you know what? I can't talk, so I'm not gonna even try to justify myself. Anyways, But this piece right here, this top piece, right? Even so, it could have like a, so on the left side here, we have a piece like this, right? With, that's half the width here of this piece. This is the full length piece. Magnetic tape, because it's nice, can be cut to size. I don't have magnetic tape, unfortunately, so well, I want to get this done soon. I can't wait 2 weeks for new supplies to come in. But that would be pretty ideal, like this, like a flat sheet magnet on both sides. It just like clicks together. But in the absence of that, we have to make do, right? And so this is kind of what the actual piece is going to look like. Right, so you have this is one surface here, and then this tab will fold into another tab, which I will draw separately, but you get the idea. It's going to be attached together. Okay, something like that. A tab like that, but with a cutout of some sort, right? Because then you can fold it together and mechanically seal that. I feel like that's our best chance. This is the simplest idea that I can come up with. Can I have it hooked together like the top of a takeout box? Top of a takeout box. Yeah, something like that. This the inspiration behind this is like, you have your little arrow, right? Something like that. And then it's like on one tab of a takeout box, and then it slides in, locks into another piece. Tabs that intersect and lock. Yes, that is exactly what I'm thinking. It's just, how do we want to custom design it for this situation? We want it to be able to be deployed really easily. This is going to be all manual, essentially. This landing gear, you're going to have to put it in, fold one side over, fold the other side, put it in the slot. How do we want to do this? So I'm gonna have a piece like, so this is gonna be one piece, this left piece right here on the top, and left, right? So this is gonna be the hinge. You can have it fold back like that. No, I feel like folded pieces are kind of tricky. Trying to think. I don't know how to do this. I have never done this before. But if we think about it, we might be able to come up with a solution. So how do we get it to stay together, right? Right now it's full length, but we could even do half length if we could somehow manage to get it to stick together, right? And so if we do half length, then I'm thinking maybe like a Y-shaped thing on one side, and then the other side just like accepts it, right? And then this This and this need to be like, it needs to come together. You know what I mean? Like this needs to snap together to really hold it in place. But if this were the case, we could even do 1/3. And yeah, the Y splits off at the first 1/3. And then the other piece is 2/3, but comes in here, and then this folds down, right? That's actually a really elegant solution, but we have no way of making this come together. It's gonna be a little bit tricky. Unless our strategy is to not fold this in the first place, let the material properties snap it together. Like, you know, paper is a little bit elastic, right? So, you know, it has some tendencies of wanting to bend back into shape. We could use that to our advantage, right? Could prototype something like that. And then this comes down here to the base where the hinge is. And then this comes down and, you know, has a simple folding hinge, not a mechanical bearing hinge, right? This could be the solution, honestly. It's just every time you assemble it, like close up the hatch, it has to be very precise. You have to be like pretty good at it to make it work. Also, we don't even know if this idea works, so it could very well not work, but I feel like this is the simplest design. We've kind of distilled it down to the main bits. We have a door that travels on a circular arc up to this fairing component here, this edge, this top edge here, right? And then we have a hatch that's 90 degrees that I don't know how we're going to keep it at this angle, to be honest. That's another question. Like, we need to lock this angle in place. Yeah, that's going to be interesting. But we'll do some prototypes with the actual material with the cardstock so that we can experiment how to lock this in place. If it's not lockable, we might have to introduce some paperclip materials, right? Like a steel wire to really hold this shape in place, like a little brace in the middle, or something like that. And then with that, this will be rigid, and then these doors will come together like that. And so in reality, it's not going to be this exaggerated. It's going to look something like this. Something like that. It's just 2 layers here, and then 1 layer in the middle that's kind of just trapped in between, so it can't just flip open willy-nilly. So the question now is, how do we get this wide, this double layer, right? So we could just simply do a piece like that, right? Singular piece like that, and then another piece that goes from here to here and here to here. That's another piece, and then it would somehow be secured at the base here. Just draw a little anchor to anchor it in place. So I think this might actually be our best option, to be honest. Let's try and make something like this work. So I want to do that. Yeah, because the nice thing about this is I think it's all right. This might actually work. Wow. Okay, so it's gonna be slanted a little bit, but you get the idea, right? All right, so for this, we would need the measurement of the side here, and the top. We already know the top, I think. Okay, write this down. I gotta measure this. This is 9.95-ish. So across the top, it's gonna be 0.95 cm. Down the side, it's going to be something else. It's gonna be 1.2 cm. All right, that looks decent. And then this angle, I don't know, but it'll have to work itself out. It'll have to lock itself in place. And for this, so if we wanted to divide it into thirds for a symmetric look here, right? So this overlapping part is right in the center, right? This middle third here. It would have to be a third of that. So I actually don't know what that is. Let's calculate that quick. Divided by 3. That's okay. So 0.31 here, and then whatever else is here. Minus 0.95. So 0.63 here. That's the division here, right? Well, we're not going to be able to measure that precisely, but get the general idea here. And then, yeah, should be good. This seam is going to be along here, so that'll be interesting. Actually, if we go halfway, so if we go like Y directly like that, and then a piece like that, that leaves a seam right down the middle. So aesthetically, that would be perfect. Okay, and we don't have to do so many weird measurements. So let's say 0.95 divided by 2, right? That's 0.475 on either side here. These are the measurements. So this is okay. This is important. All right. So the general shape of this piece is going to be interesting. First of all, of course, it's going to be interesting. If it's not interesting, I wouldn't be doing it anyways. All right. We can't have just a regular rectangle, because that'll look weird and it wouldn't fit with the aesthetic. So we need to match this piece right here, and then go all the way back here, and then maybe do like a little triangle here. So this is very, very sketch, but it's my process, and I've gotten it to work pretty well so far. So we're gonna cut this a little bit. Okay, so we cut off a little strip here, so it's a little easier to handle. I think I do have the template for this. I just don't know where it is. I could get that. Actually, let me do that real quick. It'll save some time. Ah, got it. All right, yeah, that saved a lot of time. All right, just tracing shapes. Just gotta verify that this matches up. Press that down. Right, so this side. Yeah, it works. Yep, that's the one. I only made a couple templates, so it wasn't too hard to pull out. Or that sounded weird. Anyways, to find. Anyways, okay, so this is the shape that we have. Uh, Actually, we could use this to our advantage. We could use this shape precisely to our advantage. All right, so let's grab this. So we're gonna keep our sketches to the side here. See, design sketches, right? They don't have to be beautiful. They just have to convey a simple shape or concept. And as long as you understand, then it's a success. All right. This is interesting, because this is exactly the shape we need. So as long as we're faithful to this and we don't go off geometry here, just gotta draw this line and this to lock it in place, to lock this template in place, right? So point here, oh shoot. Okay. And then just the bottom edge here, this corner right here. All right, see, like I accidentally shifted it, but since we already drew some lines, we were able to match it up again. And then yeah, this is the interesting bit here. Just fold that up, that tab up, and then just gonna get a dot there, get an edge here. Okay. And this is the other critical geometry piece. Need to get this edge right here, this corner, this vertex, because that'll determine the width of this band right here. Okay, so we have some rough shapes. So this, yep, that's one part. Okay. Okay. So, all right, so this is kind of what we need. This piece connected here. And actually, we need a little bit more here, because we want the hinge to exist as one piece as part of this. So I actually made a mistake by putting it so close to the edge. I normally do that to save space when I cut out, save material when I cut out these templates, but in this case, this was a blunder. All right, so I am going to MacGyver my way out of this situation. All right, this is a waste of tape, but it'll save us time, so. All right, problem solved. There we go. Nice. All right, so here we can just have a little bit of extra material, right? It doesn't really matter. And then this top here, the hole goes up until about maybe here. So let's just be conservative and go a little bit more. So we need to go here, and then we can make a jagged shape just to make things look cooler. Well, we could go back, it's just yeah, okay, let's go back. think that's cleaner actually without this edge. Where did I put my eraser? Eraser right here. Got this. All right, so this piece is gonna go back. So we're gonna cut out this. Cut out this. We don't want that. We don't want this. We don't want this. We don't want any of this except the white piece in the middle. So that's how we're gonna get the shape that we want. All right, and then it's snippy time. Snippy, snip, snip. All right, anyways. Trim. Trim. I'm just correcting that cut. Shoot, right. Let's cut this out real quick. Let's make our detail trims more precise so we don't have to hold on to the rest of the sheet of paper. All right, so now we can trim the details out. This is gonna be good. Oh, shoot. Okay, and then this goes up here. This base really doesn't matter, like in terms of geometry. I just decided to go with a trapezoid, but it really doesn't matter too hugely in the bigger picture because we're gonna be covering this base anyways. So I just went with what seemed like a good idea. Yeah, I'm not gonna cut that. All right, this is good as is as a template. And so essentially what we're gonna do, oh, all right, let's take this down real quick just to prevent it from going places. All right, so yeah, I've actually done some fact checking, right? Or actually fellow viewer has done some fact checking. Tape is actually cellophane, right? Cellophane is a polymer of glucose, so it's biodegradable, so it's not actually plastic. So I feel a little bit less guilty for using it in this manner. But all right, yeah, so essentially our template is going to work like this. I can demonstrate how this part will work if I just get a ruler here, unfold this on this edge tightly like that. So this fold will be the first hinge. And then this one will be the second. No duh, right? Yeah, we're gonna have to reverse this fold, but since it is dependent, functionally dependent, mark those locations there and slide this underneath. Line it up and crease. Easy. Something like that. Right? And this will hopefully, you fold this in and citation Y14A. Yeah. Kind of folds in, locks like that. This doesn't look too bad. And so it'll fit in with the other piece on the other side. And then when we want, we can disassemble that, kind of pull it apart like that. And then let the landing gear do its thing. And then put it back in. And fold that. So this is actually quite annoying. So for the purposes of development testing, I'm going to just tape this in place. God. Alright, yeah. Yeah. So I just temporarily secured it in place. No big deal. So this is kind of how the door will work. It'll fold up to one side, right? And then fold back, lock in place on the top with the other piece. This is actually double layered, and there's a little bit of tape here, so it's giving it a little bounce to the... I might actually use that to my advantage. I'm not sure if it's the double layeredness or if it's the tape that's doing most of it. This material property is interesting. We could do a real quick test with a piece of paper here. If I tape it and fold, will it bounce back? Yes. Okay. There is your answer. Tape makes things fold not as tightly. It wants to pop back out. But I'm sure double layers would also help with that. So if you just fold it by itself, it doesn't tend to want to pop back out too much. But if you fold it with a piece of tape over, it pops back very clearly here. So I think I will use that to my advantage. I'll apply a piece of tape on the hinge. And also, tape in general just makes the hinge stronger. It's like a multi-layered composite, but with tape and paper instead of carbon fiber and epoxy. It's a mechanical composite. So, okay, this looks decent. I just got to transfer this onto an actual cardstock piece, and then I need to do the other side as well. And the other side will be identical to this, just mirrored, and it'll be cut from here to here, right, half the width. And then we need to make the Y shape by attaching, probably, we can actually cut off half and then use that half here to create the Y shape, Y split ends, so that this piece can fit in. Interesting. Anyways, but we have the template now, so we can directly manufacture the part in one piece. That's pretty exciting. We're at that stage. Okay. All right, so we're going at 8:30 today, so we got an hour and a half left. Okay. Start. Interesting. Sorry, I'm just looking at my computer real quick. Let's do the update at 11. All right, there we go. Also, I need to use the restroom, so I'll be right back. But here, you can enjoy a view of what I've made so far. I'll be right back. All right, apologies for that. That's what happens when you stay caffeinated for a while. All right. So let's move this to the side. We have the template, and we are making the art now. I make 2 of these because symmetry, and also, what was I gonna say? Right, we need to modify the other side. So here we go. This goes like this, and then comes down like that. Right, and then trace that over. And goes down like that. Oh man. Yep. Just slipped. This is an art that I am still learning how to do well. It's the art of tracing tracing these templates. Cause yeah, okay, let me just rotate. Match that shape up. Nice and easy. Yeah. Because it's a very thin edge, right? And you're applying a little bit of force in towards the geometry and also down onto the paper so that you actually mark the paper, mark the working piece that you're going to cut into. So it's a nice balance there. You have to be delicate with it, but also you need to mark the actual thing. So here we go. Yeah, so this is the corner right there. This is the corner right there. Just draw a line like that. And there to the tip here. Just draw a line like that. And I think we should be good. This is the anchor. This is the door itself. This is the door, the other door, right? All right, so I can also draw another one here real quick. Line up this edge at the top. That way we don't have to trace out another edge here. Ooh, this is very close. I think we might be able to do that. We put the piece like this, or I do, because it saves material. We're conserving as much area as possible so we can create other things with the, try and be efficient with the materials that we use. Sometimes this is to my detriment because the pieces, the layout on the part that we're going to cut is just too crowded. But in this case, it's only one corner of another piece, so I'm not too concerned here. Yep, that will do the trick. And like the other piece, we're going to have to mark the fold lines. So let's just do that, mark that here. Just trace that. Gonna have to erase some of these, but it's all good. Because one of these pieces is gonna be folded from the other side, because it's a mirror piece, right? So you can't have two of the same. You fold from the other side to get the other part. So do a rough cut so that you have a little bit easier of a time cutting this, cutting these pieces out. That's not a rough cut, but this area is a little bit concave, so just want to make sure I get the right shape here. Yeah, so actually that makes it easier for either piece, not attached to each other. All right, there we go. Okay, this is the back end. Just moving it so that the shadows aren't in the way. Okay, that's good. And then this. Oh, that's a tight corner there. All right, hopefully that works. Well, that's the base. That's the anchor point, so it doesn't matter. And just do that, and then you're good. There, you got one piece done. I just gotta do the other one. This is the back, I believe. Yep. All right, that looks good. That's decent. That's a good cut. Okay, that looks good. So I'm just checking the computer real quick. Yeah. So, okay, so today's gonna be 3 hours, tomorrow's gonna be 3 hours, and then 2 weeks off. And so the next time I stream, I guess I'll have to do another 3-hour back-to-back Friday, Saturday sessions, you know. Just planning things out. Oh, wait a minute. Do I want to cut that? Yes, I do. I do want to cut that. All right. Limau. I don't know what the fuck that was. Anyways. I'm kind of losing my mind. Just low-key talking to myself. Streaming to online strangers. No big deal. Alright. So that's the scrap pieces to the side. Alright, so got 2 workable pieces here. One of the pieces has to be the opposite of the other, and it has to have the Y shape that splits open at the end. So that's gonna be interesting. Okay, so I need to, what was I gonna do? All right, so we gotta pick one to use. They are pretty much exactly the same, so it doesn't really matter which one. I'll just use this one then. The other one will be for the other side. Okay, so we have this template thing. Can lighten up this line as long as we can barely see it. We'll be good. Point to point here. Okay, I think that's good. And just quality control check. Seems all right. Maybe a little bit off on this side to the right, but overall still very workable. So yeah, I'll fold it like that. We could fold it the other way and get it to be like a very loose door, but I feel like I want to keep it so that it has a little bit of that tension right now that we need. That'll be good. And then for the other side, I'm just gonna erase this because we're not gonna be folding on this side anyway. This, I don't know why I drew that, to be honest, but it's good for reference, I guess. Because on this side, we're folding up like that. And the reason for that is so the door can actually work, right? So now this will fit over, right? Like that. It makes perfect sense to me. All right. All right. All right. I'm just gonna trim this. Rip this little edge off here. Make it a little bit easier to test fit this piece. Yep. Seems legit. It's just a massive moving piece of material, but it'll do. All right, so we might have to adjust the fit later, but the concept seems to work. It's just not a very good fit, I feel like, you know? We might have to adjust the geometry later, but for now, we just want to see if the concept works. Okay, so this is going to be interesting. It's going to be from the other side now. This side. And same principle. I'm going to fold from this corner to this corner. Is that right on the line? That's right on the line. Wow, I'm good at this. Anyways. Okay, same principle here again. Just line it up. Oh, this one actually has a line, so that's nice. Fold it in, and you got yourself a door. Nice. And so, let's cut off the other side here for the tape. Just a little snippy snip, and then rip. It doesn't really matter because it's a temporary piece. Okay, this goes on this side. This goes on this side. Whoops, no, like that. Okay. So something like that. It's gonna be what we need. It's a little bit jank. Actually, we could do a full length thing, because I feel like that would make the bottom completely seamless, and the seam would be aligned with one of these corner edges. Does it kind of make sense? So like if we keep it like that, that'll make it look cleaner. That's a good idea. I'm just gonna continue patting myself on the back with these excellent design choices. Nothing weird at all with that, you know. It's just this piece needs a little bit more definition so that it can fit better. Yeah, buddy. Okay, I think that solved a lot of the fit issues. It's just the location of how it's, you know, how it's assembled in a way. Okay, so I think we do need to adjust the geometry a little bit. So right now it looks kind of jank. All right, let's just remove that. So I think the problem with the fit here is that this base fairing is not completely rectilinear in any sense. So it's like it's a little bit slanted here, right? And it's actually a little bit curved near the front. So in order to make this work, I feel like we have to make some adjustments, like probably some cuts of some sort, you know? I don't know how to do this. What kind of shape do we want? This is literally just me drawing right now. But if we do that, that would look kind of strange. Right? But essentially everything forward of this, I would like to have it taped so that it's not moving. That means that if we were to make this thing move, no, that looks weird. I don't know, this, God, all right. So it'll unfold like that currently. Let's see. I'll just come out like that. And then come back in like that. This is not too terrible. It's just the side here, there's a little gap. We could make a completely straight cut down. It just looks a little bit weird, I feel like, you know? Looking weird is a no-no. If things don't work, that's okay. That's kind of my design shtick, I guess. All right, let's see. And this side will have another piece that fits in like that. it be easy to remove? Okay. Maybe. And then this front, God, why is this so hard? Why do I gotta make it hard for myself? I built like a fairing up front that covers that. Oh my God, we already did that. A fairing for a fairing, unbelievable. Okay, so I think this might work. Maybe. I don't know. Guys, help. I am in distress. I don't know how to do this. Seems to work. It's just a little bit not clean. If I make a cut, then it'll look ugly. Can't make it look ugly. Right? I mean, I guess it's a landing gear door, so like it could look ugly. I don't want to make this complicated. Damn it. Could do like a zigzag pattern. You know, that's what I'm thinking right here. Like a zig, zag, zig, zag. And then this whole zigzag panel comes off while the front gets to be taped down. Or we could do like a triangle piece like that. And then tape the triangle in the front down. And then the back here will still be open, so that sucks. So if we do a straight drop down from the fuselage, what would that look like? Or if we did an angled piece like that? I feel like either way it's gonna look weird. Alright. Yeah, let's just not worry about that and just get it to work first. So, if you know me, you'll know that I am an engineer by profession. So those two sides of me always fight against each other. It's like, bruh, get it to work. And then the other side is like, no, make it beautiful. And I'm just debating to myself, making trade-offs all the time. But I'm actually thinking now, like, what if I did a half cut so that they just kind of melded together? That's wild. There's gonna be like a line in the middle. That's the only problem I see with this. But we don't have to cut out another piece. That could actually work, yo. How would a line look down the middle? Just like a line like that. I feel like it interrupts the paneling. But I mean, if it's functional, then nope. We're gonna cut out another piece and we're gonna make this work. All right, got this. Just need to trace out this little rectangle ping little thing. I totally know what I'm doing. No, I don't. Alright. Sorry. Usually at this point, I quit because it's 2 hours. And actually, I have like 9 more minutes to go for a regular stream. But today, we're going extra long, so I'm gonna be exhausted after this. Anyways. Alright, just tracing that shape down, tracing this shape down, tracing this shape down, and tracing this edge down. Probably can't see anything, but that's okay. You don't need to see this boring part. Again, the whole point of these is so that you can work on your projects and I can work on mine. And I guess we could draw a line here, but I don't think that line is going to be good. Yeah, it's not going to be good. Alright, so we need to tighten up that line. So we just do connect the dots real quick. And that did the trick. And do connect the dots here. And that did the trick. So we're going with the full length Y division piece, the split end is what I'm going to call it. And that is so that we have a easier time actually making this thing. Really small lips with cardstock, those are really hard to deal with, right? Really tight, small pieces being folded. So this larger piece hopefully should give us some leeway with that. And plus, I'm just prototyping right now, so I honestly don't know what I'm doing. But if this doesn't work out, we'll go back to the 1/3 and 2/3 design, the split. But I have a feeling that we'll probably be okay here. Okay, so just cut out a part. This part is gonna go on one of these sides. I don't know which side. I'm gonna do. I'm just gonna erase some of that graphite markings here. Okay, so this, I believe, goes on the other side, and this goes on this side, and they both open up like that for the landing gear door, right? And I think for the most part, when I'm doing this, I'm probably gonna be holding it like this, and I want to lift up from this side. So I'm gonna have to give the left side the double layer, which would mean this side. So this is like a little bit user experience design. I'm right-handed, so I would like to hold it like this and open it like that. So the Y needs to be attached to here. The Y split end thing. So I hope that makes sense. If it doesn't, well, I tried. Honestly, most of the time, I don't even know what I'm talking about. That's the mind of a designer right here. All right, so I'm gonna pinch this down in place, and we're just gonna trim the edge here. And really get it to fit within the footprint of the larger piece here. See, I actually have no idea if this will work, but we will see. We will find out. All right, here we go. Moment of truth, right? Truth. Truth. I tell you, truth. Wow, that was precise. I'm really good at the. Oh, no. 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 As soon as I said that, I realized I had done fucked up. All right, let's try that again. Here we go. Oh, damn it. Why you gotta be like this? Yeet. All right, here we go. We're gonna take off this excess here. Fuck. Alright. Get rid of that. I think that should be good. And then, with this side down, this is the cover. And wait, is this the... No. Shoot. Is this the piece or this is the piece? I want that side to be the thingamajig. So this is actually the piece. Shoot, I almost screwed it up. I almost screwed it up, guys. Alright, and then this is where the fun begins. It's like putting a puzzle piece together, except you actually make the puzzle. Oh my goodness. Alright, fold this back. Put that in. Line up the edges. Did it work? Maybe? I don't know. Okay, just take our X-Acto knife, do a little trim right here. Hopefully I don't cut myself. Well, I didn't, but I also didn't cut the tape. Shoot. Alright, there we go. Okay, problem solved. Get rid of that little niblet there. Okay, so this is what's open, which is good. That's what we want. Also, we need to tape the other side because 2 hinge tapes are better than 1, right? That's not how the saying goes. No, that's not how it goes. But anyways, Rebel Pilot says, well, I'm gonna head out. Love your Ace Combat piano covers, by the way. Thanks, man. That's from like ages ago, but thanks for watching. Thanks for supporting the channel. All right, so look at that. It's a Y shape, split end there. Right. That's kind of what it looks like. And yeah, hopefully this locks in place. Yeah. Okay. It's time to assemble the landing gear cover. I can't believe I spent 2 hours on a landing gear cover. Like, that's just insane, man. That's insane. I spent 2 hours last time on the fairing, so it's not too surprising, but still. We might need to trim the split Y a little bit shorter just to enable a better fit. But that said, I'm gonna try our damn hardest to get this to work. Okay, so this is gonna be a little bit difficult, but we're gonna get it right. Okay, so we're gonna put more than half on this anchor, and then this is it's gonna be tight, yo. It's gonna be real freaking tight. All right. Oh shoot. Okay, so I'm gonna cut this. That sucks. It just broke off. Alright, just gotta pull the canards up a little bit so we have enough clearance. I think we have enough clearance. A sliced little thing here. And yes, slice here. This isn't just for aesthetics, this is actually functionally critical, because if it jams up the canards, then, well, we designed this mechanism to do nothing, because if it jams, then we can't really do anything with it. Wow, I'm being really repetitive. I apologize for that. Okay, so this, I'll just cut it straight off. Yeah. Yikes, this is not a clean job here. Okay. All right. Okay, so that seemed to do the trick. Yep. This splits open like that and closes up like that. So functionally it checks out. It's not really great fit, but let's see if that fits inside. And then that kind of wraps around. All right. So I don't think it's not like great, but it's not terrible either. It does work, it's just this piece is flapping up. Again, we might need to make some geometry adjustments here. All right, this actually is starting to look a little better to me, this slanted edge option, because that'll enable us to keep a tight front. And if we do the same in the back, we can secure the back nice and neatly. If we want to make that change, we got to make it now. We can't keep on futzing around. And let's see, what else do we need to be concerned about? Oh yeah, this tab, this split Y, I think it's a little too thick. It's too chunky. We have like, if we cut it down to the middle third, I feel like it would do the same job, but like reduce a lot of the thickness on the ends here. So I don't know, this kind of fits, but just not as tight as I want it to be. I mean, that's to be expected. This isn't a mechanical part. This is literally just folded cardstock. So, but closing off the front and the back will definitely make it a little bit cleaner. It's just if we want to do that, we have to make some geometry changes, some corrections, right? And those corrections have to be very precise. So have to match on each side. Okay, so let's see. I've disassembled this. I think for this piece right here, we're gonna reduce it down to the middle third to give it like a functionally it'll still perform the same job of, clipping onto this piece right here, right? It'll still clip on, but it's just it'll do it in a slightly better way, I guess. I don't know. Yeah, so if we were to do that, we need to measure out a little bit here. But honestly, the dual cut, the half cuts don't seem that bad right now. Because right now that would actually do the trick, but it's, this one edge that keeps on coming off, right? But if you have a half cut, it would kind of interlock. Not sure. Decisions. Also, prototypes. If we make a lot of prototypes, then we don't have to stand around to find out if it works or not. I could do tabs. Tabs, like cut a slot here, fold the tab in, a seam. You have a seam down the middle. That's the other option, right? So, which is it gonna be? Alejandro C says, Aloha. Hello. Thanks for stopping by. So I'm currently trying to figure out how to get this door to fit together nicely, which is a little bit tricky, but it's an interesting problem. I feel like this extra bit, I don't think that's helpful. I thought that was going to be useful, but I think without... Yeah, I never catch these ones live. Yep. I usually stream from 5:30 to 7:30 every Friday, but then now I missed a couple weeks, so I'm just trying to make up some time in these longer streams, which is going to be 3 hours today and 3 hours tomorrow, same time. But yeah, that's just to catch up on missed progress, I guess. Just catch up on this design here. We want to work on it. So all right, so I think this is an interesting concept, the split Y, but I don't think it works that well. But at the same time, I'm not sure if a tab would work better or if a half cut on both sides would do the trick. Because I feel like if a tab in the middle would pull this piece down, and the ends in the front and back would align. I feel like, I don't know if I'm making any sense, but so if we have this as is, right, with the split Y, it tends to open up like that, which is not desirable because it's a door. It should be shut. But if we do a half cut, it's still gonna be like that on both halves, right? It's just gonna split up on this side and then split up on that side. It's just reversed, and you have two different directions of these individual tabs. But if we make some sort of middle tab here that slides into this other piece, we might be able to solve this problem. Or if we like, let me sketch this out here real quick on a scrap piece of paper. I'm actually not sure how this would work. So if we have like a tab here off of a main piece, right, like that, and then on the other side we have just the slot there, right? This would create these open lips on each side. But if we go the other way, where we say, okay, the ends are gonna slide in to a cut. Well, then that becomes another open edge, so that's gonna be tough. Yeah, there's really no easy way around this. Wonder what would happen if we... Okay, so if we only had one door, and this one door is like slid into the other slot here. It's an interesting concept. So what I'm saying is this door right here, we only need one on one side that folds open, right? And slides into the fairing itself. That would be very good, because what's happening is the landing gear, which I taped off right here. This mechanism is spring loaded, so I just didn't want it to annoy me, so I just taped it off. But this would actually act in tension, right? So this would want to come out, but if this slid underneath the fairing, it actually compresses this shut, so it's a sealed compartment. That's actually not a bad idea. It's just this kind of looks ugly. Right? You got a seam down the middle here. Yeah. It could very well be the solution to the problem. Because sliding underneath like that, that's about as clean as we're gonna get of a solution. I feel like, yeah, that might just be the way to go. And if that's the case, well then, could I do it with the other side? Because I'm right-handed. If I want to open this, I need to use my right hand to do that, right? I wouldn't want to push like that. That's just not ergonomic. So if we put it on this side and slid it in like that. My only regret at this point is not making a clean cutout for this. This is not very straight of an edge. This could do it. This could be the solution we need. All right, yeah, I'm willing to test this out. This could actually be the end all be all. All right, so if we want to do this, we need to adjust the geometry, and we have, okay, so this is going to be our backup. If we screw this one up, we could just reverse the folds on this one, get a weakened piece, but it'll still be a piece, I guess. I don't like the asymmetry, but to keep things simple, we need to do this. So how are we gonna do this? All right, so first of all, we need to modify this side profile because this front needs to attach without a huge gap in the way. So if that's the case, then this needs to go back. And if that's the case, then this needs to go back. Okay, we're just making changes here and there and willy-nilly. But I think it'll be for the better. All right, so this is in line here. This slot is right here. So we actually need to end this door a little bit early, like that. Oh my god, this is gonna be like an exact fit. Okay, so that's that. I'm gonna cut out this little notch here so that this can fit all the way in. And then there'll be like a little gap there, and then the seam will continue along here. And then, oh my god, I'm just like talking to myself, aren't I? That's like the design process. I am losing it. This is why I keep my streams, my normal streams, to 2 hours, 10 minutes max. I start losing my sanity just talking to myself. Okay, so this is okay. Okay. Okay, so we want to have some sort of thingamajig. I don't know what angle. What's a good angle? 45? I'm gonna eyeball this. 45 degrees. There we go. End of story. Here, 45 degrees. Bam. There you go. And then this is gonna be the anchor. Anchor's still gonna be intact like that. And we're gonna cut this off. No, or we could just shift the anchor up front like that. Just continue this 45 degree. All right, fuck it. I'm doing this. Leroy Jenkins. Here we go. All right. I'm spending too much time thinking about it and not doing anything. That will get us nowhere. Plus, we have a backup, so it's all good. Plus, we have the template, so we're really good. All right, so that's that. And then I do need to cut this bit. This makes me nervous, but because we spent so much time making this piece, but we need to keep on chugging forward. We can't stop. Gotta make progress here. This is part of the prototyping frustration. It's like, damn, why didn't it work? I don't know. You tell me why it didn't work. Oh my goodness. It might actually... It might actually... Huh? Okay, hold the excitement, hold the excitement. All right, we're gonna, first of all, we're gonna erase the shit out of this graphite right here. Just because it's not sightly, not aesthetic. All right, and then, oh, all right, gotta be careful not to break this edge. All right, so that's good. Okay. I think the left side, shoot, that's gonna be this side right here. Yeah, okay. All right, we're almost there. Okay, got this. I'm still gonna keep this piece of tape on, but I'm gonna have to make it a little bit easier to take off. Oh, hopefully I don't stab myself. That would be a shame. Okay, it's up a little. Up. One back down. All right, it's up a little bit. Okay, so now we can work our magic. So I'm just gonna tape this piece right here, and then line it up with the thingamajig. Oh shoot! Fold that back. Line up this front edge. Damn, we gotta do this whole cutting thing again. Shoot. All right. Okay, let me just put this in a little bit closer here. Okay, why is this not... Okay, I mean, I guess that works. Okay, all right, whatever. We don't have time. We gotta cut this. We gotta see if it works. Gotta do this carefully. Don't want to cut the canards. Oh my goodness, I freaking ripped it again. All right, breathe, just breathe. Got this. I think that did the trick. Not sure. It might still interfere with the canards. Nope. Feels smooth to me. All right. So now we can tape the front end securely so that there's no gap, I think. Oh my god, this shape doesn't match. Why? That's really rough, but we can build our way around that with another fairing. Oh god. Oh no. All right, let's see if we can realign this real quick to get that front edge to match. Okay, more or less, yeah. But now will this fit? I feel like it will still fit. Nice. Okay, so we corrected the alignment. Sorry, I'm just like talking to myself right now, but here we go. Okay, so we need like 3/4 of this. I don't even know if that's 3/4, but whatever. Okay, that makes sense. That makes sense. Now the moment of truth, we just take off this. Oh my god. Please tell me it works. So this is landing gear deployed. And then you put it in, and then you slide this in. Okay, there's a little bit of a fit issue. Oh no, it works. Oh my god, it works. It's so ugly, but it works. Oh my goodness. No way. I can't believe I spent 2 hours on this. Honestly. What a simple solution, but it took us a long time to arrive here. So look at that. Landing gear's not popping out. It's just not a very clean solution, but it is a solution. So, I don't know. Can you call that a win? Not sure. This is likely the design that we're going to go with for these other two landing gear here. But this is looking all right. It's not too terrible, I guess, in the grand scheme of things. And then you pop this out, and the landing gear comes out. Put it back in, and slide over the cover. And there you go, you have a cover. It's definitely not ideal. It's definitely not ideal at all. It's not perfect, but it's really not what we're aiming for, right? Okay, just trimmed off a little bit for better fit here. Yeah, I'm not sure. I'm not sure about this. I mean, it does work on one hand, right? It keeps the landing gear inside. It's just not a very clean solution. I mean, look at all that. Oh, look at all those hard seams there. But, I mean, hey, kind of works. It just looks very unusual, is all. It's on normal, regular aircraft. It's seamless, or near seamless. Alright, so that's cool, it worked out. When it hits the ground after a throw, will the door stay closed or will it open? And will the landing gear pop out? That's a good question. I have not tested this. I would assume if you hit it with enough force, it will pop out. It's just, I don't know how much force that would be. But right now, it does seem like this mechanism works in the sense that these doors, they're held shut at this seam by the landing gear itself, right? It wants to come out, but it's being trapped inside by this door being caught on this lip, right? So in that sense, it is secure by itself and it doesn't pop out. But I'm wondering, like, if you hit hard enough so that you impart enough force to like pop this edge out and then the rest of it out, then it could, in theory, you know, completely come out, I guess. But this is an interesting design for sure. I don't think I've ever seen any cover like this before, but it does work. It's just a little finicky to retract the landing gear, and also there are some pretty major gaps. Like, for example, here, right? And then here in the back. these gaps are pretty large, so I'm not sure this is gonna work, um, but functionally it does what it's intended to do. It just doesn't look that great. So let me see. There was another comment here. Will the fairing eventually deform from repeated impacts? I would assume so. Um, but right now it's really stiff. Um, this is definitely not an ideal design. Let me see if I can play around with this idea here. If we make a panel like right here and buckle it in, I think that could do the trick too, and it would be much cleaner. So let's try that. This does work. I'll keep it on the back burner in case my other ideas don't work, but let's go for a cleaner solution here, right? Okay, so if I recall correctly, I did cut off this piece, the split Y idea. It didn't work, it didn't pan out, but we can use this material right here to make a direct door. Of sorts. That would be a lot cleaner. And I don't know. I think it could work if we really tried. Right, something like that. Okay, so this would require a slimmer, slightly slimmer design. Something like that. And then the sides would have to be taped directly. Oh my god, it's not working. Well, I mean, I guess, yeah, it's workable. It's workable. I'm not gonna bother finicking with that, futzing around. All right, so this could work. In theory, it's a simplified version of what we just tested, but I gotta secure this thing down, otherwise it's gonna annoy the heck out of me. Okay. All right, so let's actually assemble it on the other side, because that's the side that I am not going to take photos of. Wait, no. I am going to take photos of both sides, so it doesn't matter. I should design it according to ergonomics. Okay. That looks decent. Okay, that looks so much cleaner, right? And you just gotta make sure we tape the bottom here too. This is gonna be a precision job right here because this piece, it needs to be pretty tight, and the little lip here for the actual fairing, it's not that large. Just gotta be careful. And then this, okay, yeah, this is probably a better idea to use an X-Acto knife here. Okay. Slide that in. There we go, yep. And then you just gotta make a little notch here at the front because this hole doesn't go all the way up front. Oh man, here we go, here we go, here we go. This could be the solution that we're looking for. Why didn't I see this earlier? It took us 2 freaking hours to come to this place. Oh my goodness, I forgot the end here. I totally forgot. Oh. All right. Okay. Mark that. Cut the end here. Release it a little bit. Oh my god. I swear to god, if this works, we just wasted 2 hours trying different design ideas only to come to the simplest solution here. Okay. But then again, right, like Da Vinci, he has a quote that honestly resonates with me a lot, is that simplicity is the ultimate sophistication. It's actually harder to make things simple, right? Because you can always go complicated, like, oh, we need a hinge here, we need a hinge there, we need this slider thing, we need this and that. But when you think about it, if you really try really hard to get a simple solution, that's where the ultimate challenge is, right? So I will say this has been quite the toil, but like honestly, if I knew this design was gonna be the design that I went with, I wouldn't have spent so much time prototyping those other things, right? I would have just gone to this. I would be out of my mind to try something different. Waste so much time. But honestly, I did not know that this would be the solution. So we went around on a wild goose chase. But finally, I think we're about to arrive at a good solution here. So the only problem with this thing is that it's incredibly stiff. It's kind of hard to push in. But let's see. It's the only difficult thing about this design is the actual installation and taking out. Look at that. Aesthetically, this is so much better. So much better. Wow, that is a clean design. All right, yeah, I'm gonna call it. This is, oh my god, it only took 170 minutes to get here, but oh, I'm losing my mind. A simple fucking rectangle attached to this fairing solved our design problems. That's, oh my god. Oh, why? That's so it did the trick. It fucking did the trick. Look at that. That is so clean. That is so clean. Oh my goodness. And all it took was a little piece of tape with a little rectangle that slid into the slot, right? But like now this is the only unsightly bit, but you can justify that it's functional, so it doesn't, and you know that rough edge is actually my mistake. I didn't consider that as part of the design. But I still can't believe I spent so much time doing this. So the only way to really like deploy your landing gear at this point would be to like use a knife or something to like pry this out, because this isn't really designed for quick deployment, I guess you could say. This is like flight mode. Put it in and you fly your plane, and then when you want to display it, and you got to make sure you want to display your aircraft with the landing gear down, then you take it out. I feel like in the future I would integrate a double hinge here. Right, so like imagine this top rectangular piece connected to a little bit more material here that's cut so that this thing can flex a little bit, right? If it can flex a little bit, then it can open up and actually function as a door that doesn't get jammed. But right now, the way it is, it's, oh my god, this is like, this is so freaking tight. Like I can't, because it's literally like you fold this down, you have to buckle it to get it to slide in. There's like no other way to get it in. Um, but this is incredible. Honestly, I can't believe I spent 2 hours to arrive at this solution, but this is the solution. So in the future, forget all of this complexity and mechanical crap here. What we're going to do is make a fairing, right? It's gonna look something like this, like that, right? With a little slot here, right? I'm gonna just draw this real quick. Slot, right? And then actually, yeah, slot, we could cut like this and then directly just cut this landing gear piece into the fairing itself. So we have a final thing that kind of looks like this. Okay. Let's try this. So it opens out like that, right? And then we have a little door thingy. And then this edge slides into this little lip here. And the pretension keeps it shut. I don't know if this makes any sense to you guys, but it sure does to me. You know, this little rectangular piece is attached to a little cutout on this base fairing hinge right here. That'll enable us to have an easier time opening this. But it adds a little bit more seams and everything like that, but it's a little easier to access than this. This is like, I would say this is like a pretty semi-permanent thing, because I still haven't opened this. I mean, I could try in the next 5 minutes or so to get this this thing to work, because we're approaching our 3-hour mark. But you would have to really like lift it out to get it to come out here, right? That's how you open it. And quite frank, that's actually really difficult for me without special tools like a pencil, right? But I guess like if you're displaying, if it's for display, then it doesn't really matter. You're indoors anyways, you have the tools, but it's just for easier access next time, we're gonna have to integrate this door into the structure itself. So the front view of this structure would look something like this, right? Does that make sense? And then this tucks in nicely into this slot right here, where this tip goes here on the inside, right? So it kind of acts like that, this panel, and then the landing gear wants to come out. So that seals it up real nice and tight. So just zoom in close on this sketch, show you guys what I mean, right? This is the ultimate landing gear door. No mechanical parts, no nothing, no futs, no anything. This is just you slide this thing open and you tuck this into the slot, and then the landing gear compresses down and seals it shut. Oh my god, it only took 3 hours to come to this solution. And honestly, it's so simple, right? It's so fucking simple, but I just have to think my way around all the wrong ways to do it. You know, you do enough, you look at enough wrong ways to do something, you come up with the right way to do something, right? So that's part of the design process here. Just reading some of the comments. Will the fairing eventually deform? Yes, I already answered that. In the future iterations, will you embed the landing gear mechanism deeper into the fuselage to avoid the need for a fairing structure? That's a good question. In this design, I actually cannot do that, because if you look where this mechanism, this landing gear is, it's located right underneath the canard actuation mechanism. So you would have to plan this out really well in advance, in order to get it to work. You can definitely like have like a fuselage base, right? Like you have a fuselage base here, and then you cut out like areas where you're gonna mount the landing gear, but you also have to consider the other functions. Like if you have canards, you got to actuate that on the top, and so it's a whole architecting job right there. So yeah, the answer is yes, you could, but you would have to be a little bit more considerate in your aircraft architecture. So yeah, you can embed it deeper. I'm curious if the rear landing gear housing can somehow be blended into the airfoil of the wings. Might try that on my upcoming design. You definitely can if the wing section is thick enough, right? You can definitely integrate the landing gear inside. It's just you got to make the mechanism really compact, and you have to have a very sturdy hatch or whatever to hold the landing gear in place. But that's pretty much it for me today. This has been a 3-hour long stream. We're approaching the 3-hour mark. So thanks for watching, guys. I know like there's several of you that have stayed all the way until now. Tomorrow I will be again doing another 3-hour stream at 5:30 to 8:30. And that's really to catch up for the missing time from previous weeks that include Thanksgiving and the week of the 4th, because that was actually my sister's birthday, so I just decided to spend the time with family. But that's pretty much it for today. Keep on working on your projects, and if you have any questions, leave them in the chat and we'll discuss them. I'll try and get back in a timely fashion to them. But yeah, I guess I'll see you guys tomorrow if you're tuning in. So yeah, thanks for watching. Take care. Be safe.